So today's section about continuity of functions. But before we do that, I want to spend time on section 1.7 about precise definition of limits. I'm not sure you fully understand the concept, right? To prove the limit of the function, is equal to some numbers, and how to use we call epsilon delta language to prove that. So actually, we are not asked to find a limit. We already gave his answer, the limit. Okay, we want you to prove the statement using epsilon delta language. Okay, so the first problem I want to discuss is as follows. Show that the limit of x approaches 1, 3x, 2x divided by 5 is going to be 1. Okay. Now the limit is going to be 1. Okay, as x approaches 1 from doesn't matter from which side. Okay, x approaches 1, 3x plus 2x over 5 approaches 1. So I don't want to find the limit. Okay, actually he already gave his answer. What I really want you to do is to prove that to prove the following statement for any small real number. Okay, there is a small delta which depends on epsilon and the function. Okay, so such that this inequality will always implies that inequality. Okay, because this is what you have to prove. Now for linear function, there's a couple ways to prove. If you go to Mac to get help, the students usually show you, the tutors show you how to simplify the final inequality. Okay, then you backward to determine the value of the delta. Okay, so in other words, your target is the inequality at the end. But this is complicated inequality, so you just need to simplify. Okay, then to see what the delta you have to choose. That's the idea. So so we fixed it. Okay, given here's a proof. Okay, write down proof. Okay, given an epsilon greater than 0. Okay, then I'm going to simplify this inequality. Okay, this inequality is going to be equivalent to the following. You multiply both sides by 5, or you can combine them into 1. Okay, it's going to be minus 5, right? Clear, those two as I said. Then you multiply both sides by 5. You get 2x, 3 minus 5 is negative 2, right? It's multiply both sides by 5. It's got it? Yeah. Then you factor 2 out. Then divide both sides by 2. Okay, so that means the above inequality, very complicated inequality, is equivalent to the following simple one. What do you have to find out? We actually want to find out, let me repeat again. So this inequality is simplified as the following. So actually we want to show that for for any epsilon, because this is epsilon is our given. So just say there is a delta such that x minus 1 less than delta greater than 0 implies x minus 1 less than epsilon, right? But everybody knows that what is delta you can choose. Clearly, this delta should be equal to, can be smaller, 5/2 epsilon or smaller, doesn't matter, okay? Smaller is okay. I can put epsilon there instead of 5 epsilon/2. So the answer is not definite for the choice of the epsilon, okay? Clear? Because I want you to prove that there's a delta. If x minus 1 is absolutely less than delta, implies x minus 1 less than 5/2 epsilon. Then what is delta? You should choose. Okay, you choose let the delta to be 5 epsilon divided by 2 or smaller. Okay, so that's the end. So we find the delta. So all you have to do is just find the delta, and you verify that. This one implies that. But that the one on the right hand side is too complicated, so you simplify it. Okay, then it's easy to see what is delta you can choose. Okay, that's the logic. Okay, another argument. Here's another way to do. Another to it, I don't find the delta right away. I still find the delta at the end, but I'm not going to simplify the final inequality. Okay, what I'm going to do is just assume that x minus 1 less than delta, okay, greater than 0, okay? And this is a to be determined later, okay? Our goal is to show that under this assumption, this inequality on the right-hand side, it's complicated inequality, holds. Okay, so let's do it. Under this assumption, 3 plus 2x minus 5, this is 5, right? Minus 1. Now, I cannot say less than epsilon because we don't know yet. Right? So you are going to make sure this is less than epsilon, but it's not yet. Under the assumption, by proper choice of delta. So you cannot say just less than, otherwise you make mistakes in the logic. Okay? You cannot just put less than epsilon. Then that means your brain's chaosity, you're not thinking about mathematics correctly. If I see less than epsilon immediately, and on the top you say assume that, then at the end, you immediately write the epsilon, then you modify. That means you're not in the correct way to give, you're not given the correct argument. Okay, so you cannot assume it's less than epsilon, but you want to prove it's less than epsilon under the assumption. So before you prove it, you cannot say it is like only when you prove it he is guilty. But before it's that, otherwise you cannot call him criminal. Okay, it's just suspect. So before you prove it, you cannot say cannot call this guy criminal. Okay. So the same here. You cannot say it's less than epsilon. So let's simplify it. So you get 3 plus 2x minus 5 divided by 5. Okay, continue. It's going to be 2x minus 2 over 5. Then I take 2 out. I take a 5 out. And this is going to be that, okay? That requires very simple algebraic skill. Okay, some students still make mistakes, then I cannot help you too much on that. But you gradually you will recover, you learn more. More through the calculus course. Okay, so now you simplify to this. What is the assumption? Assumption absolute of x minus 1 is less than delta. So it's under the assumption it's less than delta. Okay, this is by the assumption. Yeah, there's every step there's a reason there. Okay, now, but that's not epsilon, right? It's 2 over 5 delta. But you really want to make it less than epsilon, right? So you say this less than epsilon if you choose this one to be epsilon, right? Otherwise, it's not true. So every step should be in logic, clearly. So then that means delta is going to be 5 epsilon over 2, right? So you find it. Okay, clearly. Now, under the assumption, absolute of x minus 1 less than delta, and this difference, big complicated, is less than 2 over 5 times delta. But that's not the epsilon yet. So you have to set this to be less than or equal to epsilon if you can make this, right? Or then you can choose that, any delta less than 5 epsilon over 2. All right, so now it's clear. Your answer will be, if you go back to the statement, is if you choose a delta to be 5 epsilon over 2 or smaller, and then so then you can say that if delta is going to be 5 epsilon over 2 or smaller, then this one implies 3 over 2 plus x over 5 minus 1 less than epsilon. Okay, why? See the above argument. Okay, so that's it. So you find the delta at the last step. I prefer this method. The reason is there are some functions complicated. You cannot simplify the final inequality directly, like what I did in the first place. Okay, you cannot do that. Okay, if you especially involve x squared. If you involve x squared, you cannot do that. Okay, for example, show that limit as x approaches 2 and x squared minus 4x plus 5 equals 1. Why equals 1? When you plug 2 for x, you get 2 squared minus 4 times 2 plus 5, that's 1. Now, this is a typical problem. It's a bonus problem on the final exam, probably not on the test. Okay, why? Because you only have one method to use, which is the second method I just mentioned to you. Number 2 is, on the way to prove it's less than epsilon, you have to make two choices on the delta. Okay, not just only one. Okay, so here's the above probably because the function is a linear function. Just at the very end, you say delta is less than or equal to 5 epsilon over 2. Okay, you're done. Okay, but then you cannot use the first method. You actually want to prove that, right? You actually want to prove that for any given epsilon greater than 0, right? You want to find the delta such that x minus 2 less than delta, greater than 0 means x is not equal to 2, implies x squared minus 4x plus 5 minus 1 less than epsilon. Right? They're not equivalent. Okay, it's just one left side implies the right hand side. But you cannot simplify the right hand side like what I did in the first method. Okay, so the only way you can do, you assume absolute x minus 2 less than delta. You choose a delta later. Maybe in several steps you have put the additional restriction on delta. Okay, there are more restriction, but you still have a solution. So what you have to do is you have to assume x minus 2 greater than 0 less than delta. Okay, assume that. You specify, you find the value of delta later. Okay, under this assumption, okay, I want to make sure the right hand side, this expression is less than epsilon, but I don't know yet. I cannot just say less than epsilon. Let me simplify. It's going to be x squared minus 4x minus 4. Okay, then I still don't see x minus 2 there. That's okay. But I see x squared minus 4x minus 4 is going to be x minus 2 squared. Great. Okay, this time we'll probably just need we only have making one assumption on delta. Okay, so this is, I already see x minus 2 less than squared. Right? My assumption says that this is less than delta squared, right? By assumption. Okay. But my goal is to make sure this is less than epsilon. So this should be less than epsilon if delta less than or equal to square epsilon. All right? Okay, this is our choice. So therefore, we can we can choose, yeah, we may choose delta less than or equal to epsilon. That's it. Then what you see that, then x minus 2 less than equal. This implies x squared minus 4x plus 5 minus 1 is less than epsilon. Okay, so we find the delta and let's repeat the statement. What do we want? What we have proved. So that's all about the proof of that's in for some problems you do have to let me modify the problem a little bit so you can see that why this method is better than another one. This one you probably still can use the first method because you only make one assumption on the delta. Okay, so if I modify the problem a little bit, put this way, yeah, show that the limit as x approaches 2, still the function not approaches 2, I can say approaches 3, okay? 4x plus 5. Let me check what is answer. 3 squared minus 4 times 3 plus 5. So 9 minus 4, minus 4. 12 is negative 3. Negative 3 plus 2, which is plus 5. It's going to be 2. Okay. Okay. So the limit is 2. So we have to prove that. All right. So to prove that, we assume that x minus 3 less than delta greater than 0. Okay. Absolute bad. But most of the time, we just need the other side of encoded because greater than 0 means x is not equal to 3. Okay. So x squared minus 4x plus 5 minus 2. Okay. That's the difference, right? I want to make sure this is less than epsilon. We cannot say that at this moment, and later on when we choose a smaller delta. Okay, there are some delta should be true. So what you get is x squared minus 4x plus 3. Then what? Then affected, you get x minus 1, x minus 3, right? Okay, so it's different from the above example. Above example, just x minus 3 squared maybe, right? So here is x minus 1, x minus 3. So you get x minus 1 times x minus 3. But I know x minus 3 is less than delta. Okay, it's going to be less than delta. But how about x minus 1? I don't like this term. So I have to put assumption on delta in order to get rid of this x here. So what I'm going to do is I assume, put addition assumption, okay? Yeah, we can, assume delta is less than equal to 1. How about like that? Okay, we cannot say fixed equal to 1. Under this assumption, x minus 3 is less than delta greater than negative delta. So what does that mean? That means x minus 3 is greater than negative 1, less than positive. So you move x to the both sides, 4 and 3 minus 2. So x is between 4 and 2 and 4. Okay, x is between 2 and 4. X minus 1 is between 3 and 1, right? So x minus 1 is between 1 and 3. So absolute of x minus 1 should be less than 3, right? Okay, under the assumption, just delta less than or equal to 1. You know the value of x, absolute x minus 1 is less than 3. So here, you can simply like that. Great, that's what I want to see. No x involved. I want to make sure this is less than epsilon. So I can say less than epsilon if delta is less than or equal to epsilon over 3. Okay, so there are two assumptions here. In order to guarantee this difference is less than epsilon. Two assumption on the way to get to that estimate. Okay, in the middle, almost the last step, you have to assume that delta is less than or equal to 1. Then the very last step, you have to assume that delta is less than or equal to epsilon over 3. So from the above argument, you see that we may choose delta to be the minimum value of 1 and epsilon over 3, okay? This means the minimum value for one of these two. Any number which is less than or equal to 1 or epsilon over 3 is fine, any positive number. Then x minus 3 less than delta really implies that difference it's less than epsilon, okay? By the above argument, we can say by the above argument. Then everything's clear. The proof is complete by logic, okay? It's important to argue with someone in logic, okay? When you're trying to argue with anyone, you know, you write down the statement, you're trying to prove something, you have to give a reason, give evidence, and in logic. Then again, give a conclusion, right? So this is a basic skill you have to have, okay? It's not only just in mathematics, you know, in other areas. Okay. So this is about abstract. Yeah, this is a abstract definition, precise definitions of the limit. Okay. Now, section 1.8. Here's the definition of the continuity. When we talk about a function, right? Here's the definition. Given given function, we want to say the function is continuous at the number, okay? Given a function, yeah. Let f be a function and on an interval on I, okay? I is usually means the interval, okay? And the number I is in the interval. This notation means in the interval. A is a number. It could be end point, okay? Then we say that f is continuous at A if the limit of the function as x approaches A exists and equal to the value. Okay. Now, what happens if A is end point? Then you can only say you can only talk about one side limit. Okay. So we just assume that A is the interior point. Then, and what is the geometrical meaning of of this continuity? If you look at the graph, here's A, okay, and Y equals f of x. The graph, so this means the function is continuous. The graph is not broken, okay? The value of the function equals the limit of the function. And in this case, it's continuous at the number A. Another picture shows you, okay, this is not going to be discontinuous. Continues at A, okay? And in other words, the graph is broken. Now, this picture shows you that the function has left-hand limit. And it also equal to the value of function. Yeah, this picture shows that. And this picture shows that x approaches A of the function equals the value of the function, right? How about this one? This picture shows that the left-hand side limit exists, not only exists equal to the value A, but the right-hand side limit does not exist. It also exists, but it's not going to be the value A, okay? And the function, yeah, the dot here, that means the, So the function is continuous from the left-hand side at A, but it's not continuous from both sides at A. Okay? So the continuity, roughly speaking, is about whether the graph is broken or not. All right, so this is the picture. So first example we want to look at is this function. F of x equals square root of x. First, find the domain of the function. The domain of this function is going to be all the x. X cannot be zero, a negative, cannot be negative. So it's going to be the interval from 0 to infinity. Okay. So what we can say? Well, clearly when x approaches 0 from positive side, this is going to be, it's going to be 0, which is going to be the value function 0. Okay. And if a is greater than 0, then you can talk about limit from both sides. But then limit from both sides, because this is a nice function, right? All you have to do is just put the a for x, and this is actually the value function. Okay, so the function is continuous on the whole interval then say, because it's also continuous at the 0 from the right-hand side. Then so then you say that the function is continuous everywhere. F is continuous at any number A in the interval. Now, sometimes you can ignore that, just say continuous in the interval. More precisely, it's continuous at any number A in the interval. A could be 0. Right? I have to say that the reason we can do that because the function is a nice function, it's elementary function. It consists of very few well-known functions. So let me repeat the fact again. This is already mentioned that before when we find the limit. Okay, so if f is an elementary function, okay, on an interval on its domain, right? The interval is going to be the domain of this function. Then f is continuous at any number in its domain. Right? So, so namely, the limit of x approaches a f of x is just equal to the value function. Okay. Remember, a should be in the interval. Okay, in the normal. Now, now if you look at the picture like this, okay, so this is going to be. Okay. So this is a graph of y equals fx. But a is not in the interval. Okay, a here is not in its domain. Okay, it is not in its domain. So you cannot even talk about continuity. You cannot say the graph is discontinuous because anyway, the graph is missing the point. It cannot define. Okay. Another picture, another graph is still same, looks like that, okay? But I put the points here, another point like that. This is y equals fx. In this case, A is in the domain of the function. Okay, A is in the domain. Okay, so you can talk about continuity of the function at point A, but the limit as A approaches as a function, as A approaches, as X approaches A from the left-hand side, this is the exists, okay, but they're not going to be the value, but it's not going to be the value. It's the same is true. This one also exists, but not equal to value. So therefore, the function is not continuous, it's discontinuous. Okay, so the function f okay. But from the graph, it's easy to see. Discontinuity means broken picture. Yeah.
So the graph preceding it, we wouldn't. You said we wouldn't even be able to talk about continuity or discontinuity.
If the number A is not in the domain.
Gotcha.
Yeah, that's a key point. Otherwise.
But the next one is in the domain.
Yeah. Then you can talk about continuity. Yeah. So when you want to prove the function is continuous at A, three conditions must met. F of A is defined. The limit should exist. Third condition, they must be equal. Exist does not equal, then that do not equal, then still discontinue. Okay. So here's the example. F of X equals x squared minus x minus 2, and here x minus 2. Okay, just given that. Okay. Now there are a couple ways to do. So just given this, then you can say the domain of the function is going to be all the x, s cannot be 2. So which is going to be this. Okay. 2 is not in the domain. So you cannot even talk about continuity. Even if you draw the graph, you see the graph kind of broken, but it's not broken over its domain. Okay, not broken over its domain. So that's why the function is continuous at any number inside its domain. Okay, I don't care the outside its domain. So if we simplify it, it is going to be like x minus 2, x plus 1, right? Yeah. So after you simplify, it's going to be just x plus 2, x plus 1. That is true for x not equal to, right? Okay, so you can talk about the limit as x approaches 2 from either side, because x approaches 2 means x not equal to, but x getting close to. So this is just x plus 1. That's 2 plus 1, which is 3. Okay? So 3 is its limit. The limit exists. But f of 2 is undefined. Okay? So that you cannot even talk about continuity. We cannot talk about continuity at the 2. Okay? In some generalized sense, okay, the function is discontinuous at point. Okay, but anyway, it's actually more precise, should be not defined. Okay, so f is undefined. Yeah, so you cannot say continued. It's not defined at all. Okay, but okay, if I give you another function. Yeah, this is another function. I give you the function. Here's x squared minus 2x. Just minus x. Yeah, this is a k if x is not equal to, if x equals 2. All right, so this is function defines it on the whole line for any x. So the domain of the function is the whole line. Okay, in this case, slight different, right? And f of 2 is going to be k. Not only that, the limit as x approaches 2, which is 3. Okay, we already find out when x approaches 2, the limit is 3. So clearly, f is continuous at 2 if and only if k should be equal to 3. Okay, k should be equal to 3. So if you look at the picture, then here's a picture. Okay, I like the graph. So this is a 3, right? So where is the function? It's going to be x plus 1. X plus 1 is like that. Okay, this is an empty circle. This is the original graph without the difference, but the value of the k is here. So that is a 3 and 2. Not 3, 2. Yeah. And this is a point 2 and 3. So the graph, the complete graph for this function will be the whole line, but with a 1 point deleted from the line, but it's somewhere else, above that or below that. Okay, now. So k is going to be 3. Only when k is 3, that means only when this dot is moved to that circle, then you get a continuous curve. Okay, then the function is continuous. Okay, so we can say that f is continuous at 2 if only if k is going to be 3. Okay. So next problem, it's also piecewise defined function. If x is not going to be 0, and here's k value, if k, yeah. My question is, can you find the value of k so that the function is continuous at 0? The answer is no. Okay, no solution. Find the k such that f is continuous, like the above problem, at x equals 0. Can we do that? The answer is no. Okay. How do you see that? Well, clearly the value of the function is defined, right? It's no problem. In order to prove it's continuous, you have to find the limit. The limit as x approaches 0. This is going to be a limit of 1 over x squared. Approaches 0 means x is getting close to 0, but x is not equal to 0. When x is not equal to 0, f of x can be replaced by 1 over x squared. And you look at this is going to be just 1 over positive 0. It's going to be positive infinity. Okay? So the limit is going to be positive infinity as x approaches 0. The value is going to be k. But infinity never be equal to k. Okay? So therefore, it's never equal to the value of the function. So in other words, if you delete the part in the middle, okay? If you remove the part in the middle, you will see that it's not going to be f of 0, right? Okay, that means f is discontinuous at 0. Because if it's continuous at 0, this above equality holds. The above equality does not hold. Okay? Okay, if you look at the graph, that's obvious. This is the graph. Okay, this is the graph. It's already broken. It goes to infinity, and this is a k. Okay, this is a k. You're not able to seal it up on the very top, and so that becomes a continuous curve. You cannot. And this is all the way to infinity, out of the universe. Okay, if you can imagine, just right? Yeah, it's hard to imagine, but watch out some videos called Universe, and you will see that. Yeah, far away from the Earth, and you will see that you are the only small animal on the very tiny dust in the space. That's true, yeah. That was a picture about this. Where's the Earth? In the Milky Way. Very tiny, small dust here. All right. Yeah, so this is a picture. All right, so let's look at another function. Here's the next problem. It's also our favorite example. Given a function is cx squared plus 2x, if x is less than 2, x cubed minus cx, if x is greater than or equal to 2. Okay? Find the value of c such that f is continuous at 2. Okay, so the function is two pieces here. If you draw the graph, there's two pieces. It's like you are going to, build a bridge from both sides, right? And you have to just justify the parameters so that it can match exactly. Then you make a bridge. Otherwise, it's broken, right? It's displaced. So this is the idea. Now, if you want to draw the graph for each piece, on the left-hand side of 2, right-hand side of 2, and for general arbitrary value of c, then you find out that that's displaced. So the question is, here's a 2, right? And this side, x less than 2, it's probably, I don't know, just like a parabola, okay? So this is empty, okay? On the right-hand side, 2, it's not even parabola, it's a very strange function, it's a polynomial, okay? So it's going to be like that, but this is a dot. Okay, I just draw the picture like that. So you need when you change the value of the c, both sides changes, but eventually they're getting close, then they meet. Okay, so you have to find that values. How to do that? Well, continuous at c means all you have to do is make sure x approaches 2 of the function equals f of 0 of 2. Okay, so look at this. You have to find the value of c so that this equality holds, but at least you know the value of 2. The value of 2, you get 2q minus 2 times c, it's 8 minus 2c, okay? Because x function is defined for x greater than or equal to 2. When x equals 2, you use a second piece. So now let's the limit. I think the function has a right limit, has left limit. Okay, so let's find the function from when x approaches 2 from positive side. If x approaches 2 from positive side, x is greater than 2, but again, close 2. So you can replace it by this function. Right, so you get cx. So let's put 2 here, 2q minus 2 times c. I think this is nothing but the value of function. So you already get the value of function. No problem. So now let's look at the left-hand limit. So the left-hand limit, it's going to be limited as x approaches 2. And this is what is the original function. So cx squared plus 2x. This is a piece on the left-hand side of 2. And then you get, if we plug 2 for x, so you get 4c plus 4. All right, so, but this is not going to be the value of f2, okay, in general. Now, first of all, you have to make sure the limit exists, right? The limit exists if and only if those two limits match. So that means 8 minus 2c is 4c plus 4, okay? Those two should be matched, okay? And then you get 4 equals 6c, right? 4 equals, so c is going to be 2 over 3, I guess. Yeah, c equals 2 over 3. So when c equals 2 over 3, this limit exists. Not only it exists, it's equal to the value of the function, okay? So if c equals 2 over 3, then the limit not only exists, but equal to the value of the function, because the right-hand limit is already equal to the value of the function. Okay. So we solve the problem. Now, why we want to study the intermediate, the continuous function? Continuous function means, roughly speaking, means the graph is not broken. Okay, for continuous function, the graph is not broken. So here's a function. Okay, and this is a and the b, close the interval. It's continuous, right? Continuous, and probably this is not necessarily the highest point. So this is a value of b, this is a value of a, that's a graph. So if the function is continuous, the graph, there's no hole in the graph, okay? So we assume that f is continuous everywhere on the interval from a to b closed, okay? So there's no hole in the along this curve in the space. So that means for an arbitrary value k, so for k between f of a and f of b, because I don't know which one is large, okay? Then, well, no, the line, the horizontal line intersects the graph. Okay, somewhere at x equals a, okay, at x equals c in the interval from a to b. Clear? Somewhere. You see? Okay, there are two intersections, but I just only one. Somewhere, right? I just need at least at 1 point. All right, so this is clear from the picture by the continuity. Okay. Now let me explain this. What does that mean, intersects? Intersects really means f of x equals k has at least one solution, one root, c, in the interval from a to b. Okay. All right. Whoa, so this is a simple application. We're talking about solutions of equations now. Given equation, how do you know there is a solution, right? Now we have some nice efficient way to check whether the equation has a solution. Okay, how do you check? All I have to check is, yeah, so we have the theorem. We have the theorem. So if k is between f of A and f of B, any value, then this equation has at least one solution. Now, the solution usually called the root, but it's a solution, okay? All right, you have to solve for that. So, but you cannot write down the specific number in many cases, but you can guarantee there is a solution, okay? So let's look at the following problem. Okay, I consider the following equation: x to the first minus x plus 2. Okay, it's going to be 0. Okay, let's try to solve it. And you are not able to use any formula to write down the solution. Okay, we only have a quadratic formula, but there's also a formula, mathematical manual for some engineers for general polynomial of degree up 2, 3, and 4. You can express the solutions in terms of coefficients. But the mathematicians already proved that for general polynomial degree 5 above, the solutions cannot be determined by the coefficients, cannot be expressed by the coefficients using elementary function, I should say that, okay? Of course, it's determined by coefficients because given coefficients of a polynomial, then you have a given unique polynomial, then it has solution. Right? So, but there's no formula, general formula for the solutions expressed in terms of coefficients. No. When we say express, you have to use the well-known function, like radicals, sine, cosine, blah, 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 right? So this is I think this was proved by a young guy when he was only 21 years old, but he passed away right after that. Fighting, kill them each other. Okay, so few hundred years ago, so mathematicians usually from the wealthy family, they have nothing to do, just enjoy mathematics, stay home, don't worry about food, clothing, and they just have private tutors at home and study mathematics. So when I look at those mathematicians of history, this is what happened. But these days is different. Okay, if you someday if you just have enough time, curious about these professors at Stanford University, like a math department, will check their background, where they're from. Age above 60 probably, or 50, 70, even earlier. Many of them actually farmers. Okay, they're from their parents are farmers. Okay, not surprised. All right. They just feel boring. They don't want to stay on the farm. That's all. Okay. And he's good. Mathematics, okay, good to math department. That's no choice. Not like here. You have so many choices. Oh, which one I have to study? I'm so good in math. I study engineering, right? You choose engineering. They want to choose mathematics. Okay. All right. So x to the first minus x plus 2. So let's try to find the solutions. Okay. And how many of them? We cannot find the exact value, but I try to find the solution in some intervals. Okay. So I'll consider the value. Okay. So I can even just put this. I can say 2. It doesn't matter. Okay. So I can even put 3 here. So it doesn't matter. Okay. So the above equations really means this is going to be 1, right? So then if we simplify, you get x squared minus x squared. So really, yes, these two are equivalent equations. All right, so I want to find a solution for the above equation. Okay, so what I'm going to do, I randomly pick up a value, okay, f of 0, it's going to be 3. Okay, 3 is larger than 1. I can choose -1 or -2. Yeah, negative 1 is going to be negative 1 is negative, positive. Yeah, it's still positive. Okay, so negative 2. Negative 2/5 minus negative 2 plus 3, which is negative 2. Well, it's a very large number, right? Plus 5. It's clearly it's negative, right? Because 2 to the 5th is 32. 32 is negative. All right, so it's less than 1. So clearly 0 is between 1 and 3, right? Okay, so that means according to the above theorem, okay, this equation has at least one solution in the interval from -2 and 0. Wow, when I not only get the solution, I also get the estimate. So this is -2, here's 0, that's a 3, and this is very negative number. So the graph goes, okay, so this is a function. So what we're trying to do is we find the line y equals 1, okay? So there's the intersection point. And I guess if we really want to get better estimate, because the intervals between -2 and 0 is a little bit large, but I already tell you, yes, there's a solution between -2 and 0. You'll be surprised without telling you the theorem, okay? But I also want to look at the value of f -1. If I look at the value of f -1, I want to see what is that. This is going to be -1 to the 5th minus -1 plus 3, all right? So this will be -1. It's actually canceled out. It's a 3. Again, it's going to be like that, okay? So when x equals -1, it goes back. So what does that mean? That means actually the 0 is actually in the interval between -2 and the positive because 1 is less than 3, which is f of -1, greater than 0, which is f or even greater than that, right? F of -2. F of negative is negative now. So 1 is between those two values. Okay, therefore, f of x equals 1 and has at least one solution in the interval from -2 to negative. So yeah, I get a smaller interval. Just look at the value of the endpoint at the two endpoints. If there's between yeah. If there are one number is larger than 1 and one number is smaller than 1, then you're done. You know you're going to have a solution. Okay, but f of x could be just x cubed x to the 5th minus x. So let's quickly look at another problem, then I'm done. Okay, so you consider the function x squared minus 3 plus 1 of x equals 0. And this is on the interval from 0 and 2, okay? And we want to make sure this has a solution, right? So what I'm going to do, I know this is a, all right, I know f of 1 is going to be 1 squared minus 3 plus 1 over 1, which is going to be negative. This is a -2 plus 1, it's -1. So it's negative, right? Okay. And I know as x approaches 0 from positive side, and this is going to be positive infinity. The reason is the first term approaches 0, second term is approaches 0, minus 3 plus positive, right? So it's going to be positive infinity. So that means somewhere close to 0, it has a positive sign. So let's use 1 over 10. Okay, 1 over 10 is going to be 1 over 10 squared minus 3 plus 1 over 1 over 10. So actually, this is a positive number, okay? It's going to be 1 over 100. And here 10 minus it's a 7. Actually, it's positive, okay? So it's a positive number. So one number is negative, other one is positive. So that means by the continuity, yeah, so this have the opposite sign, right? 0 is between, yeah, 0 is between f of 1 and f of 1 over 10, okay? So that means f of x equals 0 has at least one solution in the interval from 1 over 10 and 1. So you get a solution. It's guaranteed there is one solution there. Okay? It's hard to solve it because it is not a quadratic formula. It's not a quadratic function. So this x squared minus 2 plus 1 over x equals 0. This equation indeed has a solution between 1 over 10 and 1. You cannot prove that this is yeah, you have to use we call it intermediate value theorem. Yeah, as long as the function is continuous, all you have to do is just verify this function has opposite sign at the two endpoint, because you're looking for the solution for this one f of x equals 0. Okay, so this is a very useful theorem to show that some equation has a solution in certain interval. Sometimes the interval, you have to find out the interval by yourself, okay? Yeah, that's it. We're going to have a quiz.